All right. Okay, question 13. In Ocean Town, there are 5 different coins, as is values. Okay, I'm just going to say A, B, C, D, E. Okay, so this you can just solve algebraically. So 4A in 1B, 2B in 1C, 2C in 1D, 4D in 1E. And the question is, how many A's are there in 1E? So what you can do is you can just start substituting. So we know that 1E equals 4D. Now 1D equals 2C, so 4D equals quadruple of that. So you have to do 4 times 2C, which is equal to 8C. And then we also know that 1C equals 2B, so 8C is going to be equal to 8 times 2B. So 8 times 2B, which is equal to 16B. And then if you go to B, we have 1B equals 4A, so 16B equals 16 times 4A, which is equal to 64A. So the answer to our question, how many A's are there in 1E, is 64. Option C. Okay, which of the following statements, if true, most weakens Ying's argument? So again, find the main conclusion, right? Find the main conclusion, and it's pretty much right here. We should all buy soybean oil instead of palm oil for cooking. So soybean over palm for cooking. Okay, these are the key words you have to think about. And then you want to find out any supporting premises that Ying has provided in his argument. I found out that growing palm oil trees requires vast, so large areas of rainforest to be cut down. To help save the rainforest and animals that live in them, we must stop buying palm oil. So his main reason is that palm oils destroy habitats, palm oils require rainforest to be cut down. Okay, so what he's saying is he's proposing a solution which is soybean is better than palm oil for the environment and for protecting habitats. Now, how do we weaken his argument? Go through the options, okay? So A, palm oil is also used in bath products. That's not relevant. We're talking about cooking here, okay? So again, keep it within the frame of the passage. B, people are using less oil in cooking than they used to. Again, not relevant because it's not really differentiating between soybean and palm, and it's not weakening his argument. Option C, growing soybeans also involves the destruction of rainforests. Perfect, because it actually shows us that Ying's suggestion backfires as it fails to achieve the main goal of saving rainforests and animal habitats, right? It actually backfires. So why would you preference soybean over palm oil? Makes no sense. So that very effectively weakens Ying's argument. Palm oil is more frequently listed in recipes than soybean oil. Again, that's very much not weakening because you can easily argue against that and say, why don't we just substitute the palm oil with soybean oil in the recipes, right? It's not exactly targeting the core premise of the environmental impact of palm oil. So that's why D doesn't really do anything. C is the best option at weakening because it's most relevant and most specific to the core premise, okay? So what's the main reason? Well, the main reason behind his argument is the environmental impact of palm oil. But hey, what if growing soybeans is just as bad as palm oil, right? That would sufficiently weaken his argument. All right, question 15. So this is a question which I think you can draw a Venn diagram for. So we have 3 activities: rollerblading, roller skating, ice skating. So I'm just going to use the abbreviations of RB for rollerblading, RS for roller skating, and IS for ice skating. So first of all, one thing I want you guys to pay attention to is skim this quickly, and it says here that anyone who can rollerblade can ice skate, and anyone who can ice skate can rollerblade. So notice how, oops, let me redo that. Okay, notice that this statement and this statement, they're both talking about the same 2 categories of rollerblade and ice skating. So basically, what we can assume from that is that the category of people who rollerblade is the same as the category of people who ice skate and vice versa. So we only actually need two circles. So the first circle would be those who can rollerblade and ice skate. Does that make sense? So this is just one circle, one entity, because everyone who can rollerblade can ice skate and everyone who can ice skate can rollerblade. So it's just one circle, right? There's no need for two circles, because if there were two separate circles, then that would imply that there's some people who can rollerblade who can't ice skate, or some people who can ice skate who can't rollerblade. So there's just one circle, okay, for the two statements in yellow. And then the next statement we have is anyone who can rollerblade can roller skate. Okay, so that's just everyone who can rollerblade can roller skate, so that's going to look like this. Okay, that's it. And then we don't have to worry about C. C is not really, well, C is relevant because it just shows that our diagram is correct. Not everyone who can roller skate can rollerblade. Yep, so our diagram is correct. There are people who can roller skate who can't rollerblade. Alright, so Shane has been ice skating for years. He will have no problem roller skating. Yes, because if Shane can ice skate, so he's in that smaller circle, he can definitely roller skate. Hannah is unable to rollerblade. She won't be able to roller skate. No, not necessarily, because maybe Hannah is here, where Hannah can't rollerblade, but maybe she can still roller skate. So Talia is wrong, because there's a possibility that Hannah could still be able to roller skate. Okay, so whose reasoning is correct? Way only. Alright, so this question looks very intimidating, but it's actually quite easy. You just have to go back to the core principle of understanding the rules. What are the rules? And I think there's only one rule, okay? So find the rule. So let's read this together. The string of symbols below contains only 4 symbols, dollar, and at, and hashtag. What is the only one of these 4 symbols that can be added on the right-hand side of the string to ensure that, and the rule is as follows, there is no repetition of 3 consecutive symbols anywhere in the string. Okay, so what are we doing? We're adding a symbol. So we're adding one symbol on the right-hand side of the string, and we want no repetition of 3 consecutive symbols. So if we're adding a symbol here, then basically the 3 symbols that we're looking at will start with and, at, and something. So we don't want any repetition of a particular series of 3 symbols. So what you want to look for actually is, where do we have and at? Where do we have and at? Well, we have and at here. So we have and at hashtag, right? That's one of the 3 consecutive symbols. So we can't have a hashtag, because if we had a hashtag, that would mean that there was a repetition of the 3 consecutive symbols. So this can't be a hashtag. So we can eliminate option D. Where else do we have and at? Well, we have and at $sign. So that means this can't be a dollar, because if that was a $sign, again, there's a repetition. So we can eliminate the $sign. Where else do we have and at? We have and at, right? So we can't have at, right? We can't have at here. So we can eliminate option C. That means option B must be our answer. Done. That's all it is. Okay? So if we had and at, and there would be no other similar 3 consecutive symbols anywhere in the string. Okay, question 17. So this one is conditional reasoning once again, but we have a long-winded passage. It's very confusing. You might be thinking, what on earth is going on? It's not too difficult, but it's just a lot of information to deal with. So the key question is, which of the following is not possible? Okay, so let me just highlight that and let's break down exactly what's happening. So first of all, we have a series of logical statements, okay? So I'm going to underline them for you guys. The first one is this: her only chance of persuading her to come is if her brother, Sam, is playing in the school band. Okay, so what is this statement saying? It's saying that for Rhiannon to come, Sam must be playing in the school band. So this is a necessary condition. Sam playing in the school band is a necessary condition for Rhiannon to come. Does that make sense? So you can actually represent this in a little Venn diagram, which I'll do right here. So for Rhiannon to come, so let's just write Rhiannon or Rhi comes to school play. Okay, so that's a smaller circle. A necessary condition is that Sam plays in school band, okay? All right. Now, the problem is it's very hard to get accepted into the band since the standards are very high. Even some very talented musicians have been turned away. Okay, you need to really impress the music teacher at audition to stand a chance. So this is the next necessary condition. So how do we know it's a necessary condition? Because of the word need. So what's the necessary condition for Sam to play in the school band? Impressing the music teacher. So he needs to impress the music teacher to stand a chance. So if he does play at the school band, he has definitely impressed the music teacher. So we can actually draw a larger circle encapsulating Sam plays in school band, which represents the necessary condition being fulfilled of Sam impresses music teacher. Okay? Alright, so Sam does not practice hard enough to get to that kind of level. So you have to practice hard to be able to impress the music teacher. Okay, if you don't practice hard, there's no way that Sam could impress the music teacher. Alright, so which of the following is not possible? Again, reiterating not possible. So impossible, 100% not going to happen. A, Sam impresses the music teacher at audition but is not invited to join the school band. That's very possible, because what if he impresses the music teacher, but the music teacher was like, there's still other people who are better than you, right? So he was not invited. That's still possible, as you can see based on this diagram. So this is possible. So A is not impossible. A is not the answer. B, Sam practices hard but does not impress the music teacher at audition. Very, very likely, because what if he just practices hard in the last few days? What if he practices really hard but not sufficiently to impress the music teacher? What if he just doesn't have the talent to impress the music teacher, right? There's so many things that are stopping him from being, from impressing the music teacher, right? Practicing hard is not enough to guarantee that he will impress the teacher. Sam does not impress the music teacher at audition, but Rhiannon still comes to the show. That's impossible. Why is it impossible? Because if Sam does not impress the music teacher at audition, that means he's not lying in that outer circle. So he's somewhere here, right? Sam is lying somewhere here. Then it's impossible for Rhiannon to come to the school play. Because for Rhiannon to come to the school play, there's actually two core necessary conditions. First one, Sam plays in school band, and second one, Sam impresses music teacher. So if Sam is lying all the way here, outside that circle, it's actually impossible for Rhiannon to come to the school play. Okay, so C is not possible, right? It's not possible that Rhiannon will still come to the school play. Sam is accepted into the band, but Rhiannon does not come to the show. Again, that is possible, because what if Rhiannon just doesn't feel like coming that day? What if she has other activities? What if she's caught COVID, right? There's so many things that might stop her from coming. Okay? Sam's acceptance into the band is only one of the necessary conditions for Rhiannon to come to the show. There's probably a few other ones that maybe has not been fulfilled. So D is possible, D is not the answer. Okay. Right, let's do this question. Scrub jays are a species of bird that will bury some of the nuts they collect in order to save some food for later. Scientists studying the species made an interesting discovery. So there's two conditions. First one, some scrub jays move nuts they bury if they see other scrub jays watching them bury the nuts the first time. It is only those scrub jays who have previously stolen nuts from other scrub jays that move their nuts. Okay, so what's going on? Basically, let's just write, let's first break down the second statement. It is only those scrub jays, so only those scrub jays who have previously stolen nuts from other scrub jays that move their nuts. So that means that if scrub jays moves their nuts, then we know for sure that they themselves have previously stolen nuts from other scrub jays. Okay, we know that for sure. So if they move their nuts, they themselves have previously stolen nuts from other scrub jays. Okay? And then if we go on to the first statement, some scrub jays move nuts they bury if they see other scrub jays watching them bury the nuts for the first time. Okay. So, if see other scrub jays watching them bury nuts for the first time, they may. So this is actually quite interesting. It doesn't say all, it says some. So this is not really a conditional statement because it's not guaranteeing that the next course of action will definitely occur. It's not if X and Y, it's rather if X, maybe Y, because here it's saying some. Some is the key word here. So They may move their nuts, but we don't know for sure. Okay, so let's just go through the statements. Logan, that means a scrub jay must be able to predict which other scrub jay will steal its nuts. No, that is incorrect because it doesn't say anywhere in the passage about the scrub jay's ability to predict who will steal its nuts, right? It never says anywhere must be able to predict, right? How can we know for sure? If Logan said they may be able to predict which other scrub jays will steal its nuts, that's probable because that can be a viable inference from the first statement. But Logan says must be able to predict, and there's no evidence whatsoever backing that claim up because must is very weighty. Must is saying 100% of the time scrub jays will know for sure if other scrub jays will steal its nuts. Never says anywhere that. Okay, so Logan is wrong. But Kimberly says if a scrub jay moves a nut it has buried, you can be sure it has had its nuts stolen before. Kimberly is also wrong because Kimberly has misinterpreted statement 2. Okay, if you read statement 2 carefully, and we've already broken down what's going on, scrub jays will move their nuts if they themselves are culpable. They themselves are, robbers who have stolen nuts themselves, right? You can't say they have had nuts stolen from them. No, it's the scrub jays who had previously stolen nuts themselves who move their nuts, right? So Kimberly has misinterpreted statement 2, so you have to be very precise when you're analysing the language, right? Especially in an exam when you're really nervous and you're trying to skim the passage. Make sure you're always precise, which is obviously challenging, but doing a lot of practice will help, and also underlying keywords would help as well. So both of them are wrong. Option D is our answer. Okay, let's go on to our next question. Question 19, problem solving. In a game called Splot, there are tokens that are worth 2 points, 5 points, or 10 points. I have one pile of 2-point tokens, one pile of 5-point tokens, and one pile of 10-point tokens. So that just means, each token is worth 2 points, whatever. Each pile contains the same number of tokens. So what I'm going to do is I'm going to give this number of tokens a value. Let's just call it n, which is the number of tokens in each pile. Okay, so we've got that. And then it says the combined total of 2 of the piles of tokens is 96 points. We'll come back to that. Let's just work out a formula for the value of the token. So for the 2-point tokens, we will have the number of tokens, which is n, times by 2 points. Okay, so that pile is going to have a value of 2n, or 2 times n. As for the pile of 5-point tokens, it's going to be 5 points times the number of tokens. And we're going to use n again because each pile has the same number of tokens. And n is just an arbitrary figure that we've given for the number of tokens in each pile. And then for 10 points, it's just 10n. So it says the combined total of 2 of the pile of tokens is 96 points. So, okay, we just have to guess and check which of the piles it could be. Could it be 2n and 5n? Well, 2n plus 5n is 7n. But could 7n equal 96? No, it can't, because 96 is not divisible by 7. So that won't work. What if we tried 2n and 10n? So those are the 2 piles, 2n and 10n, that's going to have a value of 12n, right? 12n. And can 12n equal 96? Yeah, because 96 is divisible by 12. And if we were to just double check the other option, there's only one more option, which is the 5n and 10n pile. So that's a combined value of 15n. 96 is not divisible by 15, so that won't work. So it must be, the 2 pile of tokens must be the 2-point and the 10-point, right? So that's going to have a total value of 12n. 12n equals 96, so n equals 96 divided by 12, which, as you guys should know, is 8. So that means there are 8 tokens in each pile, because we said n equals the number of tokens in each pile, that equals 8. So there are 8 tokens in each pile. So the question is, what is the total of the other pile of tokens? Well, the other pile of tokens is 5n, right? The 5-point tokens. And we know now that there are 8 tokens, right? So that's going to have a value of what? Well, 5-point tokens, 8 tokens, value of 5 times 8 points, which is 40 points. Therefore, B is our answer.